All right, this is about section 9.5, solving using the quadratic formula. Now, completing the square will work for every quadratic equation, and that's what you just did in the last section, is you learned how to complete the square. And every quadratic equation can be expressed in the standard form. So by completing the square with the standard form itself, a formula for solving quadratic equations can be found. So I'm going to show you how we're going to take the standard form right here, something that we know to be true, and then we're going to manipulate it by using the completing the square, taking the root, all those things that we've been learning, and derive at a quadratic formula. I don't expect you to be able to do this. I just want you to watch and see how they came up with the formula at this time. So we're going to take the, let's go ahead and hopefully that didn't mess things up. Okay, let's go ahead and put up here the rules that we were using in the previous section. So if you remember, the first thing you're supposed to do with that standard form, right, is simplify the ax squared plus bx equals minus c form. So I'm going to subtract c from both sides. And then the next thing is it says if the quadratic coefficient a is not 1, then divide both sides by a, so it is 1. Well, at this point, a, b, and c are representing numbers, integers, right? And so we're going to assume a is not 1 at this time, and we're going to go ahead and divide it by a. So we're going to divide each term by a. When we do that, what happens is this a and this a here cancel out to be 1. That was the whole point. We wanted to get a 1x squared plus, now we have the fraction b divided by a, x equals negative c divided by a. Now we're going to complete the square. What can we add here that would make that left side of the equation a perfect trinomial square? So we're going to complete the square. You all know how to do that. You're going to look at the coefficient of the linear term, and you're going to half it. Remember, we've been halving it. You're going to take that result then, and you're going to square it. And that gives you the perfect square that you want to then add to both sides of the equation. So that's what I've done. I've taken this result and I've added it to the right side. And I've also added it to the left side, except for I kept it in this squared form. They're equivalent, so I can do that. I'm still adding the same value to both sides. From here then, we want to do step 4. We're going to factor the left side of the equation and simplify the right. Well, before we factor the left, I want to talk about the right side. If you notice that on the right side of the equation, the first fraction is divided by 4a squared and the second fraction is divided by a. So they do not have a common denominator. And so we need to create a common denominator, and we do that by multiplying the second fraction by 4 over a divided by 4 over a. Remember, 4 over a divided by 4a is 1. You can get by with multiplying 1 times anything without having to do it to both sides. And by doing that then, we end up with having a common denominator. So now they're both of the denominators here are 4a squared. Then we took the left side, which is a perfect trinomial square, right? And we factored it. Once you have that, then you're ready to do step 5. You're going to extract the root from both sides. Remember to include the plus minus. So I'm going to take this here, and all I've done here is I rewrote this so that you see that this is b minus 4a, and it's a nicer form, and now I'm going to extract the root. What happens here is that the square root and the square, right, they cancel each other out, and you end up with just the radicand outside of the radical. And then you also want to remember, right, the plus or minus. Here, the radical, the whole fraction is in one big radical. Here we put the fraction where it's a radical in the numerator and a radical in the denominator. Those are the same thing. Remember, we can do that. So I want to look right here at this square root 4a squared. Well, the square root of 4 is 2, and the square root of a squared is a. So that can come out of the radical and become just 2a here. And that's all I've done. And I've just rewritten this so that it looks like a different form, but it's still a fraction. Now at this point we can solve for x, right? And then check our solution. So right now they are adding this to the x, so we're going to subtract both sides by that value, and we end up with a negative b divided by 2a. All right, plus or minus the square root of b squared minus 4ac all over 2a. Because these have a common denominator of 2a, we then can rewrite it to where everything that's in the numerator is on top all over the denominator 2a. This right here in the green is our quadratic formula. So we started with the standard form, we manipulated it, and we derived this formula that's called the quadratic formula. Now what's nice about that, you already have x equals, and remember a, b, and c are integers, so all you have to do is identify a, b, and c, plug in those numbers, and you now know what x is. Now we're going to do that. But first we need to learn how to identify the values of a, b, and c. So here's the standard form. I have given you this equation. And as you can see, we have 7x squared plus 3x minus 2 equals 0. I need to identify what value is a, what value is b, and what value is c. When I do that, I find that a equals 7, b equals 3, and c equals a negative 2. Look at this quadratic equation. Can you tell me what a, b, and c is? In fact, what is a? If you thought a equals a negative 2, you would be wrong. Remember, standard form, the a must be positive, and in this case, the a is a negative 2. So I have to make it positive. In order to do that, I have to multiply the entire equation by a negative 1. So this negative 1 becomes a positive, negative 1 times negative 4 becomes positive, and then of course the negative 9, or the negative 1 times positive 9 becomes a negative. So all that did was change my signs for me. Once it's in standard form and the coefficient of the quadratic term is positive, now you can find the values of a, b, and c. So a is 2, b is 4, and c is a negative 9. Try this equation. What is the values of a, b, and c? On a, if you said it was 4/3, you would be wrong. Because remember, we want to clear fractions by multiplying the least common denominator to make coefficients integers. All right? So if you had a fraction in any one of these, you would want to clear the fraction first. So right here we have 4/3. So I'm going to multiply the entire equation by 3 so that I can clear that fraction, because what happens is 3 divided by 3 cancels out and you're left with 4. And then 3 times a negative 3 gives you a negative 9, and then 3 times 5 gives you 15. So once you've cleared the fractions, you know that this coefficient of the x squared is positive. You've got to make sure it's in standard form. Is it in standard form? No, because this 15 is still on the right-hand side. It's not set equal to 0. So we have to subtract 15 from both sides, so it's now set equal to 0. Now it's in standard form, and now we can identify. So a equals 4, b equals a negative 9, and c equals a negative 15. You have to excuse me, I have a cold today, so I sound funny and I'm kind of coughing. Apologize for that. Now we're going to I'm going to give you a quadratic equation. We're going to identify the values a, b, and c, and then we're going to substitute those values into our quadratic formula and simplify. So here we go. Here is our equation, 2x squared minus 5x equals 2. Well, we want to write it in standard form, right? That's what we're doing right here first, standard form. I'm going to subtract or add 2 to both sides, excuse me. And that gives me, now it's set equal to 0. This is positive. There isn't any fractions in the equations. So now at this point, I can identify a, b, and c, which I've done. A equals 2, b equals -5, and c equals 2. Now we can substitute those values into the quadratic formula. So for every place here, for every place that there is an a, we're going to plug in 2. Where every place there's a b, we're going to substitute in -5. And then also where c, we're going to substitute in 2. So that's what I've done here. I've just substituted those values in. Now pay close attention here. This is very important. This is b squared. Notice that b was a -5. I put it in parentheses. So always put your value in parentheses when you're squaring this because this means that you're taking -5 times -5, which gives you a positive 25. You want to include that negative, and that's why you've got to put that parentheses around it. That's very, very important because you want to make sure you're getting the correct signs. The other thing I want you to realize is here, this is minus b. So I have my minus sign here, but b was a -5. So I'm left with a minus minus. Okay, so we got to pay attention to that. This negative times this negative times negative becomes a positive 5. Of course, I already talked to you about the -5 times -5 squared, right? That gives you 25. The 4 times 2 times 2 gives you the -16, and then 2 times 2 in the denominator gives you 4. So all I'm doing at this point is I'm simplifying and using my order of operations. 25 minus 16 gives me the square root of 9, right? Ask yourself, can you simplify the radical? In this case, we can. Well, square root of 9 is 3. So we end up with 5 plus or minus 3 divided by 4. From here, you can simplify again. If you think of this as 5 plus 3, you're going to get 8 divided by 4, which is 2. Or if you think of it as 5 minus 3, then you're going to get 2/4, which is 1/2. So here are your two solutions. Remember, you're going to be getting two solutions with quadratic equations. You're going to take those values and then plug them in to your original equation right here, right, and do your check step. All right, so now here's an equation that I would like you to try. Stop the video, and then once you've got it worked out, restart the video and see how you did. So if you recall, the first thing we're going to do is we're going to write it in standard form. It's already set equal to 0, but we have a negative here. So I have to multiply the entire equation by -1 so that I can end up with a positive coefficient for that x squared. Once I have that, then now I can identify the values of a, b, and c. Hopefully you got a is 4, b is 2, and c is a -5. If you didn't start with the same a, b, and c values that I have, then you probably got a wrong answer. So that's just real key. Now we're going to substitute in those values into the quadratic equation, and then we're going to simplify using the order of operations. So 2 squared here gives me 4, and then this -4 times 4 times -5 gives me 80, and of course 2 times 4 on the denominator gives me 8. But 4 plus 80 also simplifies to 84. Again, you're going to ask, can you simplify the square root 84? You're going to ask what factors of, or are there any factors of 84 that are perfect squares? And if it has more than one, you want to take the greatest one. So in this case, 84 is the same thing as 4 times 21. So this here is the same thing as 4 times 21. I did that so that when I take the square root of 4, it becomes 2 and comes outside of the radical. So I'm left with 2 square root 21. From here, we want to say, can we reduce? Well, you cannot add the negative 2 plus minus 2 because they're not like terms. All right, so you can't combine them. But you can ask yourself, is there a common factor? Can you factor it again? Well, if you notice, they're both being multiplied by 2 because 2 times negative 1 is a negative 2. 2 times the square root of 21 is 2 square root 21. So all I've done is distributed that 2 back out. Once I've done that, then I can take this 2 eighths, and 2 goes into 2 1 times, 2 goes into 8 4 times, and it reduces. That leaves me with negative 1 plus or minus the square root of 21 divided by 4. So that is your answer. I want to make sure that you go and you look at page 323 at the top. There's a note on correct versus incorrect ways of reducing fraction. Notice here, 2 was being multiplied. So this is a factor and this is a factor. Because they're factors, I was canceling out common factors, right? I canceled out common factors. All right. A common mistake that a lot of people make is right here. A lot of people will do this. They'll say, well, 2 goes in that 1 time, 2 goes in that 4 times, 2 goes in that 1 time. You can't. You're adding or subtracting here, right? Okay, these are not common factors. So doing it here would be wrong. Doing it at this point when they're factors is the correct way. So make sure you look at page 323 because that's a real common mistake. All right, this is a common mistake, and so you don't want to do that. So make sure that you look at that. And that's it for this section.